So thank you. So I will just tell you what's the plan for the future. So you just saw that you have to deal quite a lot with GRIB1 and GRIB2 and sometimes mixture of the two in the same file and so on. But we are now in a big project that started many years ago already, and with many other people involved than myself, where the plan is to migrate everything we produce at ECMWF in GRIB2 only and stop producing GRIB1. And that's going to happen in cycle 50R2, which is not the next cycle, because we are I think just started the E-suite for 50R1, but after that one, so probably same time of the year next year, we'll do the GRIB2 migration. And the scope of the migration is quite ambitious, because the plan is to migrate all parameters. So not only what we produce, but we will also define the metadata for other parameters that we don't necessarily produce on a daily basis, but that are used in other data sets. That said, we are not going to convert any existing data that we have in the archive, because we have, I think we passed the exabyte of data in the Mars archive. So we are not going to reread everything. It would take years to just read and convert everything. So that will be staying in GRIB1, but you will have tools to convert to GRIB2 as you want. And with that, it means that we need to adapt our software stack and everything. And EC codes, as you've seen, is one of them. But there will be several other piece of software or packages that will adapt as well, like InPGen and EarthKit and so on. And the requirement that we have is we try to be as least disturbing as possible for the users, but there will be some disturbance. And this presentation is essentially to try to tell you in advance what you can expect from this migration, and so that you have a chance to adapt your workflows if you work a lot with GRIB. So as I said, right now we are in the transition phase, in the sense, because up to now, which is the actual cycle, we were working in the background to prepare for the migration, but we are entering the migration phase, where we will essentially transition from a mixture of the two editions to only edition 2. And it is starting now with ERA6. So we are working on the new reanalysis, and the idea is that ERA6 will be produced entirely in GRIB edition 2. And the production is starting very soon for release for users in a couple of years, I think, because it takes some time to produce everything. And then next year, as I said, will be 50R2, where we produce the full GRIB2. And then after the migration, we are basically, after the migration, everything will be fine. But you will still be able to decode using EC codes our old GRIB1 data. And for this work, we have been working quite a lot behind the scenes, extending the GRIB2 data format by working a lot with WMO. And what we've been doing is essentially extending the templates that are used in GRIB2 to handle a lot of type of parameters that were not available as GRIB2. They are available as GRIB1 as hard-coded locally defined parameter, but they were not officially supported by WMO. So we proposed a lot of new template to encode many things. I've put a list here, and we have many other things, but that's essentially what we've been doing. And in parallel to that, we have been proposing new code table entries to encode a lot of different things, mostly for destinationers and AR6, but also some other parameters that will be used in operation. And you probably saw with the presentation with my colleague from user support that the way ECCode works is that you have an independent layer that is not or that hides, in a sense, which edition you use behind the scene, and that's why ECCode is very handy for that. If you use those keys like short names, param ID, level, and so on, those are identical in both editions because they are not real metadata key inside the data format itself. They are high-level aliases, and basically they translate behind the scenes to low-level keys. And essentially, if we do a good work, you shouldn't have to fiddle with the low-level keys. You could just use the abstraction layer, or what we call the abstraction layer, which is the part that is in green on this slide. And most of our work is to make sure that we have everything in that abstraction layer so that you don't have to care about which edition you have in your file. That said, in the future, when we will be full GRIB2, that will be a lot easier. And to illustrate that, I've just picked one parameter and just put in that table what are the real keys or that are the real code behind the scenes inside the GRIB message. And you see that in GRIB1 it's fairly straightforward, but it doesn't really contain metadata. It's just an entry with a number in a table that is also a number, and that's probably what a lot of people are familiar with when they do mask request and they have to write those param as a number dot another number. That's those two numbers. But in GRIB2, we've been doing a lot of work so that the metadata is very rich and very precise. And that's why in GRIB2 you typically have a lot more keys to set behind the scenes. But you don't have to set these keys, as Paul and Yeet shown, is if you use short names or param IDs, it's essentially these keys that are set behind the scenes for you, but you don't have to set them. But what is nice with that is that you can really encode very precisely what's the metadata, and so even if you don't use ECCodes, other decoder will be able to extract these keys and have the information without knowing a priori what's in the file. And as part of the migration, we are also rearranging how we define some of the parameters. And a big chunk of that is all those parameters that are processed in time. So anything that is averages, minimum over time period, maximum, accumulation, standard deviation, and so on. And basically, across the last 20 years, things were added a bit in an ad hoc way without like an overall design in a sense. So as part of the transition to GRIB2, we are essentially cleaning up and rearranging things in a well-defined way with a design in mind. And that's what you see on the screen. So typically, you will still have your base parameter that are typically instantaneous parameter as plain param IDs. But then anything that is maximum temperature, like daily or in the last 6 hours, will be covered by generic parameters or param ID without a reference to time. And the time or the range, in a sense, for which the parameter is defined will be captured by a new keyword called time span. We extend that for monthly means or monthly maximum or monthly minimum, because sometimes you may want to go further and for instance, compute the monthly means of the daily maximum. So if you want to have what's the daily maximum temperature of January, on average, you will be able to encode these, and that will be done using the stream keyword that will be reworked to indicate that you are doing post-processing work, and then a new keyword that is called stat type. And this stat type will take several values that will be useful and describe what is the exact post-processing you're doing. And because of that, we are going to deprecate a lot of existing, or not a lot, but a fair chunk of existing parameters or short names. And that's typically all the parameters that contain in the last 6 hours or 3 hours or 12 hours or since previous post-processing and so on. Because all these will be now handled by a generic short name that is not containing any reference to time, because that will be handled by this new timespan keyword. So typically, if you are used to using MN2T6, which is the minimum 2-meter temperature in the last 6 hours, it will become min2T, and then you will have timespan equal 6 hours, and then you can request these parameter at 6, 12, 18, and so on. Another thing we are doing is changing some parameters to adopt the WMO units, because the GRIB2 standard don't let you choose the units, your preferred units in a sense. Those units are prescribed. And typically for precipitation at ECMWF, we've always been doing precipitation parameters in meter, while the official units defined by WMO is kilogram per square meter. So there is just a conversion factor, but we are going to change that. And to change that, instead of reusing the same paramedi and the same short name and everything, we are creating new ones to avoid confusions, or to avoid people retrieving that data from the archive and making a request that goes over the day we will migrate, and they end up in a file with parameter with 2 different units. So to make that clear, we are splitting things neatly. Another thing is we are typically retiring all the parameters that contain a reference to a level with a number. So you may be familiar with the soil level, and typically it's like soil moisture level 1, soil moisture level 2, soil moisture level 3. We see in the future that as the model becomes more advanced, we'll have more and more levels, and we don't want to keep creating new paramedies and making things much more complicated. So the idea is to move those parameters to a new type of level called soil level, and then the level will be 1, 2, 3, 4, 5, 6, 7, and as we create new levels, we'll have this, and the parameter is becoming generic, and it's just like soil moisture or soil temperature, and it doesn't reference level anymore. We are doing the same for height levels, because for a lot of application like wind farms and so on, we have user requesting more and more parameter at specific height above ground, like 50 meter, 100 meter, 200 meter, and so on. And some people would like 75 meters or 25 meters. And we are not going to create parameter each time someone wants, for instance, the UV at a specific height. So instead of that, we are creating a new type of level, or a new left type in Mars called height level, HL. And similarly to the pressure level that has the level referencing the value in Pascal or hectopascal, we will have now the level keyword that will reference the height above ground in meter. So you can do left type HL and then level 50, 100, 200, 300, and then you will get your parameters at those heights. There is two exceptions to that. It's the parameters that are below or equal to 10 meter. We keep those as surface parameter because they are heavily used by almost everyone. So 2T will stay 2T. It will not be T at 2 meter. it will stay 2T on left type SFC, and it's the same for 10U and 10V. They will stay at 10 meters because those parameters are well established, and we didn't feel that changing this will be, we felt that it would be too disturbing for nearly every users. As I mentioned previously, we are standardizing those short names. So an example is that now if you have a base parameter, for instance 2T, but it can be any other parameter, if you know the short name of your base parameter and you decide that you are interested in the minimum of that parameter or the maximum or the average, then you know that the short name will be that base parameter prefixed with the minimum underscore, min underscore, max underscore, average underscore, and so on. And then if you are interested in hourly data, then you use time span equal 1H. If you are interested in 3 hourly, it's 3H. Now we have a specific value for time span that is for accumulation, because in a lot of data set, we typically don't do rolling accumulation, but accumulation from the start of the forecast. So typically you have the step range is typically 0 to 3, 0 to 6, 0 to 9, and so on. And those in the new design would jump from time span 1, then 3, then 6, then 9, then 12, and we don't want to do that. So for the accumulation and the accumulation only, that are accumulated since the start, we use a time span from start, and then your parameter is TP and so on. Then I mentioned that once you do monthly statistics, that would be captured by a new stream that is statistical processing, either for deterministic, and that will be STTD, or for ensemble STTE. And then the stat type will tell you if you do monthly means or monthly maximum or monthly minimum or and so on. And so that will be the new way, but that will not happen until next year when we introduce 50R2. And that will allow us to do a lot more things, because for instance, for ERA 6, we are going to produce a lot of statistical post-process product, and that will be helpful in that context, and then we will use it also in operation. I mentioned briefly the units. I said the precipitation one case, but another case is typically all the cloud covers that are, I think, in fraction, and WMO defines them in %. So there will be a factor of 100 between the two. That's not the end of the world. And yeah, so that's how we will handle the units. Another thing we need to handle in the as part of the conversion to GRIB2 is that sometimes param ID were used in the wrong context, and it was possible because they were just hard-coded numbers. Now that the metadata is essentially used to derive the high-level keys, you can't, for instance, use an instantaneous param ID to encode a monthly means, which is things that has been done a lot in the past, typically in GRIB1. But in GRIB2, you can't do this because the metadata will not be in agreement with the high-level keys, and essentially you can't do this. So as part of the migration, we are also changing this. So typically, when we will migrate, some param ID will change for the monthly means, because those monthly means were essentially encoded using instantaneous param ID instead of using average of the parameter param ID. Then we are introducing a lot of new features as part of this migration, and one of them is splitting all the parameters we have in IFS compo, so for the atmospheric composition, because we have seen in the past years an explosion of parameters, essentially because we have a couple of hundreds of chemical species, and then for each new parameter or new observable that you want to introduce in the model, you directly need to create 200 parameters, and that was not sustainable. So what we've decided to do is to split those existing compo parameter into two keywords or two keys in EC codes. One would be the observable or the property, the parameter, and that will stay as param-ID. And then we create a new degree of freedom, in a sense, which will be chem-ID. And that chem-ID will be ozone or carbon dioxide or methane. And then you can use all three if you want, CO2, CH4, and so on. So that's something we are going to introduce first in the next atmospheric composition reanalysis that will start producing roughly at the same time as ERA 6. It's called EAC5, I think. And so that will be the first data set using this new way. But then once we go to 50R2, once we do the IFS compo of 50R2, it will also use these things. And as I've mentioned here, we are also considering splitting specifically the emissions, because we are seeing that a lot of those new properties that are introduced are emission from a specific source, and that's typically emission from of methane from livestock, or emission from road usage, or from industries, and so on. And we see a lot of these, and if we are not careful, we might be back to square one, creating a lot of new param-IDs because of those different source of emissions. Another development that we are doing is that we are introducing for optical parameter a new keyword called wavelengths, and that keyword is essentially there to capture wavelengths in nanometer. And if I give an example, optical depth, we see a lot of parameter in our parameter database, and people now are requesting more of them at specific wavelengths, and that's typically because they want to compare that field to satellite measurements that are done at a specific wavelength or bandwidth. So we are introducing this new keyword that will capture typically 500 nanometer, or between 500 and 505 nanometer, and so on. So this will be also introduced in 50R2. And that means retiring a lot of parameters that are at some nanometer, and we will replace that by generic parameters like optical depth or absorptions, or any, in a sense. Another thing that we are considering is to rework the channels for simulated satellite images. And we are working on this. We are not done yet, but some work is done on that end as well. Then one thing that we are introducing that will not be used always as a Mars keywords or in the Mars language, but that will be always present in any GRIB file, is introducing the model name and the model version in a user-friendly way. So you will be able to do a GRIB-ls minus print or minus p model name and model version, and instead of getting a number because it was not mapped up to now, you will get a proper name and a proper model version. So you will be able essentially to print or query for IFS and then which cycle it is, or if it's AIFS, or if it's EFAS, or if it is NEMO, and so on. We will have a set of model names and model version. And if it's important for you to know for a specific field which model and which version of that model has produced the field, you will be able to query those two keys from the files. It will be introduced. I think it's already introduced, for instance, for AIFS, but it will be introduced as part of the migration. One of the big work, and I think I kept that for the end to not lose everyone, is that we are going to discontinue the wave stream. So if you are familiar with the Mars language, you know that typically for any atmospheric stream, you have a corresponding wave stream, and it's essentially duplicating everything. And in that wave stream, you just have the waves that are all on left type SFC and so on. So what we've been doing, we've been working on moving that back, because it makes sense that the waves are co-located with the atmospheric data as well, because they go together in a sense. So we've been working on retiring the wave stream and basically move back this data into the normal base stream in a sense. So wave will go in upper and wave will go in info and so on. But what you will see in the Mars tree is the introduction of a new node called param type. It will not be required in the Mars requests as it is decided now. It might change in the future, but as it's decided now, the Mars client will fill that keyword for you to get the correct data. But essentially, this param type is going to be there to separate the parameters of different type. And at the moment, for the wave, we have base, and then that's all the traditional atmospheric parameters. Then we have wave for the wave specific parameter, like significant height and so on and so on. And then we have a param type wave spectra, which will only contain the 2D wave spectra that has frequency and direction. But this param type is also introduced because we are going to use it with what I've discussed previously, which is the chemical parameter. So you could have in the same tree, in a sense, a new entry param type equal chemical, and that's for all the parameters that will depend on the chem ID. We'll have param type optical, which is for all the parameters that depend on the wavelength. And then we can even do chemical optical if you have, for instance, the optical depth at whatever nanometer of ozone. And so that's param ID, chem ID, and wavelengths that will go in a different param type. And we know already that in the future, it will also be used with param type equal tile to introduce for the land surface modeling the tiling scheme. So typically, in this context, you will be able to, for instance, request the 2-meter temperature of a lake or the 2-meter temperature of a city, because in some grid box, the grid box will be split into fractions of different patch in a sense. So that's one use for this. It seems to be a lot of changes, but we are preparing a lot of things to support people in the migration. The first thing I want to mention is the reference data sets that we have made available to users. There is one on the HPC. I believe this link is still accurate. If not, I will change it in the slides I upload to the course. But you can also get them directly from our website. So if you go to this data ECMWF int MTG2 sample, you will be able to get some data. We'll refresh it as we find things, because we might still change a couple of things, but not so much. The second thing I want to mention, and we haven't started working on it, but we are planning to work on a request translator. So I've mentioned a lot of keyword being introduced, or some keyword removed, or things moving, like a wave moving to upper and so on. So we are planning to write a tool that will essentially take a request the old way and produce what would be the corresponding request in the new world. And so that's the idea, and it should work as well for dissemination requests for people that are using our dissemination service. We also, and I think this is nearly completed and working. I need to check with the development section, but we are also working on a conversion tool that will convert your GRIB1 messages or existing legacy GRIB1 messages we have in the archive. You'll be able to convert them in GRIB2 the new way, and we hope that it will help a lot users. So if I just mention the timeline, so we are roughly somewhere there in the middle of Q4 and so on. And the idea is to implement, it's probably shifting now more at the middle of Q4 than at the beginning of Q4, we will see. So that's the target. The target is the red box that says production. That's when we plan to have this 50R2 released. But as I said, we have the sample data set ready for users to use as a mock-up if they want to update their workflows. But as soon as 50R1 will be in production, we plan to almost, or as quick as possible, start straight away with the e-suite of that cycle, which will be producing full GRIB2. And as you see, this e-suite period will be probably twice longer than what we usually do for e-suites to give people time to adapt to this. And I think I'm done. I will just conclude with a couple of QR code if you want to go and see different things. So those things are quite interesting. We have a specific page, I want to mention this page, that is called parameter changes. So everything I've been talking now at a high level, we have this page that is basically listing every single change that we are planning to do. So go to this parameter change page. We have been working on a newsletter and an InfoCris article, but that's a bit outdated now, so I don't recommend going there. It's nice to read for background, more detailed background, but the timelines might not be as accurate as I've been presenting today. If it's important for you to be up to date in the progression of this migration up to next year, I really recommend you to subscribe to our mailing list. So we have a specific mailing list where we typically give infos about when a new version of the sample dataset is released, or when things gets available, or if a new version of ECCode is released with potential changes that may break already today your workflows. So just, yeah, that's a good way to be up to date. And yeah, I want to mention that Paul and one of my colleagues, Robert, are maintaining MTG2 pages on Confluence on the user support side, and those are a very good source of information. So please go there and have a look. Thank you.